For 3 decades, the global technology story has had a fixed geography. Innovation happens in Silicon Valley, manufacturing happens somewhere else. The Valley designs the future. Asia assembles it. That division shaped the modern economy. It created trillion-dollar American firms, a venture capital aristocracy, and a mythology of garages turning into empires. But that model is breaking. Because in the technologies that will define the next era, semiconductors, electric vehicles, batteries, drones, telecom infrastructure, robotics, design without manufacturing depth is not dominance. It is dependency. And dependency in geopolitics is weakness. The next tech superpower will not simply write better code. It will control production capacity, supply chains, and industrial scale. And today, the city that best embodies that model is Shenzhen, not Silicon Valley. Silicon Valley's system is built around venture capital. A founder raises funding, builds a product, scales user growth, seeks acquisition or IPO. It is extraordinarily efficient at producing high-margin software platforms. It is far less efficient at producing capital-intensive, hardware-dependent technologies. Why? Because hardware demands long investment horizons, heavy capital expenditure, tight supply chain coordination, regulatory navigation, state-level industrial strategy. Venture capital, by design, optimizes for speed and exit. Manufacturing optimizes for scale and endurance. These logics are not aligned. Shenzhen operates under a different model, one rooted in industrial policy. In 1980, China designated Shenzhen a special economic zone. It offered tax incentives, regulatory flexibility, and direct state support for infrastructure. The results are measurable. In 1980, Shenzhen's GDP was negligible. Today, it exceeds $470 billion annually, larger than many countries. Its population grew from roughly 60,000 to over 17 million in 4 decades. That is not organic startup growth. That is coordinated industrial expansion. The single most underreported advantage of Shenzhen is density. Within a small geographic radius exist thousands of component suppliers, PCB manufacturers, battery cell producers, display manufacturers, injection molding facilities, final assembly plants. The ecosystem allows rapid hardware iteration. In Silicon Valley, hardware prototyping often requires international coordination. Design in California, fabrication in Asia, shipping delays, multi-week iteration cycles. In Shenzhen, design and production occur within the same ecosystem. The Huawei electronics market, often described as the world's largest electronics component marketplace, provides near-instant access to parts. Engineers can source components physically rather than through long distributor chains. The time compression is strategic. In emerging fields like robotics or IoT devices, iteration speed determines survival. If you can revise hardware in days rather than months, your probability of dominance rises dramatically. Consider DJI. Founded in 2006 in Shenzhen, DJI now controls an estimated 70 to 80% of the global consumer drone market. This is not marketing dominance, it is manufacturing dominance. DJI's advantage comes from tight integration of hardware and software, proximity to component suppliers, vertical integration, scale efficiencies. The company can iterate hardware designs rapidly because its suppliers are local. American competitors struggled not because they lacked engineering talent, but because they lacked ecosystem depth. As drone technology became strategically significant for agriculture, cinematography, and even military applications, DJI's market share translated into geopolitical concern. The United States government has placed restrictions on DJI usage in certain federal contexts. But restrictions do not erase industrial advantage. They merely acknowledge it. Next, consider Huawei. At its peak, Huawei was the largest supplier of telecommunications equipment globally and a leader in 5G infrastructure. Telecom infrastructure is not a consumer app. It is the backbone of digital sovereignty. 5G networks require advanced radio equipment, base stations, semiconductor components, long-term R&D. Huawei invested billions annually into R&D, reportedly over $20 billion in some recent years. The United States restricted Huawei's access to advanced semiconductor manufacturing through export controls. This highlights the stakes. Telecom infrastructure defines who sets technical standards and who captures downstream ecosystem value. Silicon Valley produces apps that run on networks. Huawei builds the networks themselves. Control the network and you shape the ecosystem. If software defined the 2010s, energy systems will define the 2020s. The global transition to electric vehicles is reshaping supply chains around batteries and critical minerals. China produces roughly 70% of the world's lithium-ion batteries. Companies like BYD, headquartered in Shenzhen, have become global EV leaders. BYD surpassed Tesla in total vehicle production volume in recent years, particularly when counting plug-in hybrids. Its strength lies not just in branding, but in vertical integration. BYD manufactures batteries, semiconductors, power electronics, vehicle assembly. This reduces dependency on external suppliers and shields against supply shocks. Meanwhile, China processes a significant share of global rare earth elements and battery minerals. Energy transition is not just climate policy, it is industrial power. The most critical battlefield is semiconductors, advanced chips power, AI systems, military hardware, telecommunications, data centers. The most advanced chip fabrication is currently led by TSMC in Taiwan and firms like Samsung in South Korea. China remains behind in cutting-edge node manufacturing. However, the broader semiconductor ecosystem, packaging, testing, materials assembly, still involves extensive Chinese participation. The United States has imposed export controls to limit China's access to advanced chip manufacturing tools. This is not a symbolic policy. It is recognition that semiconductor dominance equals strategic dominance. Shenzhen's ecosystem does not yet lead at the 3-nanometer frontier, but it integrates downstream hardware manufacturing at scale. And in technology competition, control over integration layers can be as powerful as control over the frontier node. Silicon Valley is built on market mythology. The idea that free markets and private capital alone generate innovation. Shenzhen represents a different philosophy: state-guided capitalism. China's government sets 5-year plans, directs capital toward priority industries, subsidizes strategic sectors, and coordinates infrastructure at scale. Critics argue this distorts markets. Supporters argue it accelerates national capacity. Empirically, it has produced the world's largest high-speed rail network, dominance in solar panel manufacturing, leadership in battery production, global-scale telecom infrastructure firms. In solar panels, for example, China controls roughly 80% of global manufacturing capacity. That scale reduces costs and drives out competitors. This is not accidental. It is policy-driven. The COVID-19 pandemic exposed a reality many policymakers ignored. Global supply chains are concentrated. Medical equipment, pharmaceuticals, electronics components. Many depended heavily on Chinese manufacturing. When supply chains freeze, economies stall. Industrial capacity is not just economic leverage, it is geopolitical leverage. The city of Shenzhen is deeply embedded in those supply chains. Its port infrastructure, logistics networks, and manufacturing clusters make it central to global electronics trade. While Silicon Valley produces intellectual property, Shenzhen controls physical throughput. In a crisis, physical throughput matters more. Artificial intelligence is often framed as a software race, but AI systems depend on high-performance chips, data centers, energy infrastructure. Data centers require hardware supply chains. Robotics requires sensors, actuators, precision components. Autonomous vehicles require LiDAR, cameras, and embedded systems. All of these depend on manufacturing ecosystems. China has heavily subsidized AI hardware startups and robotics development. Shenzhen's density accelerates prototyping in embodied AI, systems that interact with the physical world. In future industrial automation, proximity between AI developers and hardware suppliers could become decisive. This is not a story of American decline. Silicon Valley remains dominant in software platforms, venture capital networks, foundational AI research, semiconductor design firms like NVIDIA. But dominance in design without control over fabrication creates vulnerability. During the global chip shortage, even American firms face supply constraints because supply is physical, and physical capacity is geographically concentrated. The question is not whether Shenzhen will replace Silicon Valley. The question is which model scales better in the technologies that matter most. The 2010s rewarded platforms and network effects. The 2020s are rewarding energy systems, industrial automation, hardware integration, strategic manufacturing. These domains require coordination, scale, and policy alignment. Shenzhen is optimized for those variables. Silicon Valley is optimized for software disruption. Different strengths, different futures. Technology power used to mean market capitalization. Now, it increasingly means supply chain resilience, manufacturing depth, infrastructure control, hardware integration, strategic autonomy. Shenzhen embodies that shift. It is not glamorous. It does not rely on mythology. It relies on density, coordination, and scale. Silicon Valley still designs the digital layer, but Shenzhen builds the physical layer beneath it. And in the coming decades, the physical layer may determine who sets the rules. The next tech superpower will not simply invent the future, it will manufacture it. And right now, the city best positioned to do that is Shenzhen.